Every winter, Delhi's air becomes hazardous. Emergency measures follow. Construction is halted. Schools close. Traffic restrictions are announced. And then, as temperatures rise, the crisis fades not because it was solved, but because the atmosphere changed. This cycle has repeated for years. Cities like London, Los Angeles, and Beijing once faced air pollution levels comparable to, or worse than, Delhi's winter smog. Today, their air is significantly cleaner. Delhi's is not. This video explains what those cities changed, why Delhi's pollution persists, and what this tells us about how air pollution is actually solved. To understand Delhi's air pollution, we first need clarity on what people are actually breathing. The most dangerous pollutant in Delhi's air is PM 2.5, particulate matter smaller than 2.5 microns. To picture that size, a human hair is about 70 microns thick. PM 2.5 particles are nearly 30 times thinner. At this scale, the body's natural defenses stop working. Larger particles are caught by the nose or throat. PM 2.5 passes straight through, reaches the deepest parts of the lungs, and from there enters the bloodstream. Once inside the blood, these particles don't stay in the lungs. They circulate through the body, triggering inflammation in blood vessels, stressing the heart, and affecting organs far from the lungs. This is why air pollution is linked not only to asthma, but also to heart attacks, strokes, adverse pregnancy outcomes, and cognitive impacts. Now consider how much of this pollution Delhi is exposed to. The World Health Organization's safe annual limit for PM 2.5 is 5 micrograms per cubic meter. Delhi's annual average typically ranges between 80 and 100 micrograms, about 15 to 20 times higher. During severe winter episodes, daily averages often exceed 300 micrograms, and short-term spikes have crossed 500, according to Central Pollution Control Board data. At these concentrations, the air is not slightly unsafe. It is chemically aggressive. This brings us to the Air Quality Index, or AQI. AQI is a communication tool. It compresses multiple pollutants into a single number so the public can respond quickly. But AQI hides an important reality. An AQI of 400 is not twice as bad as 200. Health damage does not increase in a straight line. At high concentrations, pollutants interact, inflammation accelerates, and physiological stress multiplies. This is why hospitals see sudden surges in respiratory and cardiac cases during peak pollution weeks. According to the Global Burden of Disease study, air pollution contributes to more than 1.6 million premature deaths every year in India. For Delhi specifically, long-term exposure is estimated to reduce average life expectancy by roughly 8 to 12 years, depending on assumptions. This damage does not happen only on smoggy days. It accumulates quietly, month after month. Which brings us to the atmosphere. Pollution levels depend not just on emissions, but on how well the air disperses them. Delhi sits deep in the Indo-Gangetic Plain, far from coastal winds. In winter, temperature inversions become common. Cold air settles near the ground. Warmer air sits above it. This acts like a lid on a pot, trapping everything released near the surface. Wind speeds drop. Vertical mixing collapses. Pollutants build up hour after hour. The same emissions that disperse in summer become dangerous in winter. Now look at the sources. Delhi and the surrounding national capital region generate pollution from multiple activities: road transport, construction dust, industrial fuel use, waste burning, and power generation. No single source dominates throughout the year. In October and November, crop residue burning in Punjab and Haryana adds a sharp, short-term spike. Satellite imagery from NASA and ISRO shows thousands of fire events during this period. Prevailing northwesterly winds then carry this smoke directly into Delhi's airshed. This explains why pollution peaks suddenly each year, but it does not explain why the air is unhealthy even outside peak weeks. Source apportionment studies by IIT Kanpur, IIT Delhi, and the Indian Institute of Tropical Meteorology show that local sources within Delhi dominate pollution on an annual basis, even if stubble burning worsens the worst days. This distinction matters. Peak pollution creates headlines. Baseline pollution determines long-term health damage. Transport plays a central role in that baseline. Delhi has one of the highest vehicle densities in India. Despite a large metro network, private vehicle ownership keeps rising with income and urban sprawl. In 2020, India adopted BS6 fuel and vehicle emission standards, dramatically reducing emissions per vehicle. But the number of vehicles, and kilometers driven, continues to increase. This creates a rebound effect. Cleaner vehicles reduce emissions per kilometer. More driving increases total emissions. The gains flatten out. Construction dust adds another persistent layer. Delhi is in constant redevelopment: roads, flyovers, housing, commercial projects. Fine dust from construction contributes heavily to both PM10 and PM 2.5. Dust control rules exist, but enforcement is fragmented across municipal bodies, development authorities, and contractors. No single agency is responsible for cumulative exposure. Power generation is often misunderstood. Delhi itself has limited coal-based power plants. But neighboring states, Haryana, Uttar Pradesh, and Rajasthan, host coal plants that supply electricity to the northern grid. These plants exist because coal remains a reliable baseload source, grid-scale storage is limited, and land and cooling water are available outside dense cities. During winter, electricity demand rises just as atmospheric dispersion weakens. Coal emissions released far from Delhi still raise background pollution levels inside the city. Air does not respect state boundaries. Waste burning adds yet another layer. Despite bans, open garbage burning continues in parts of the city, especially in winter when waste volumes rise and decomposition slows. Each source looks manageable in isolation. Together, under inversion conditions, they compound. Now consider governance. Delhi's airshed spans multiple states. But authority is divided across municipalities, state governments, and central ministries. Transport, construction, power, and agriculture fall under different institutions. Courts intervene. Emergency measures are announced, but responsibility for outcomes is fragmented. This creates a system designed to react to visible crises, not to reduce exposure steadily. To see what works, look elsewhere. London's air crisis peaked during the Great Smog of 1952, which caused thousands of deaths. The response was the Clean Air Acts of 1956 and 1968, which banned coal burning in cities and enforced fuel transitions over decades. By the late 1970s, smoke and sulfur dioxide levels had fallen by more than 80%. Los Angeles, once infamous for smog, created regional air quality authorities, mandated catalytic converters, tightened fuel standards, and regulated refineries. Between 1980 and 2015, major pollutants fell by 60 to 80%, even as population and economic activity increased. Beijing offers a recent example. After extreme PM2.5 episodes in 2013, China launched a region-wide plan, cutting coal use, relocating industries, and coordinating across provinces. Between 2013 and 2017, average PM2.5 levels in Beijing fell by roughly 35 to 40%, with further declines afterward. These cities differ politically and economically, but they share key features. They treated the airshed as the unit of governance. They targeted emissions, not just exposure. And they sustained action for years, not weeks. Delhi already has data, monitoring, technology, and awareness. What it lacks is alignment between a regional atmospheric system and fragmented institutions. As long as air pollution is treated as a winter emergency rather than a year-round exposure problem, the outcome will repeat. Delhi's air crisis is not a failure of science. It is not a mystery. It is the consequence of treating a structural problem with episodic solutions. Until that changes, every winter will look familiar. This is not just a story about bad air. It is a story about how systems behave when responsibility is diffused and solutions are short-term. Cities that cleaned their air did not fight smog every winter. They changed how energy, transport, and industry worked, consistently, over time. Delhi's pollution persists not because it cannot be solved, but because it is still being treated as an emergency instead of an exposure problem. Thanks for watching. Please like and share video if you find it useful.